We have another problem with the areas. This time, instead of finding the area under the curve, we will be looking for the area between curves. So the formula will stay same, but we're gonna think about in this way, guys. Look at that. If I would like to find out, right, the curve between these f of f and g, what would I do? I would first, right, calculate, right, the area under the curve of, right, the area of g of x under this curve, and I would calculate, right, the area of f of x under this curve. Then I would subtract them. That's the formula actually saying us, look at that. I will calculate the area, right, for the f, and then I will calculate, right, for the g, and then I will just, right, subtract them in between these bounds. That's the idea behind the area between curves problem. You can think in this way, since we're gonna try to solve different type of examples to see what kind of problem we can have. Look, please always think, okay, the f is the above curve, okay, the above curve, and then look at, please, the g, the curve below, right, or the below curve. So if you look at it in this way, okay, since there will be some cases, okay, you need to separate the below curve and the above curve, okay, in different areas. That is why it is important to see the problem in this way. If you continue doing in this way, guys, that's gonna be fine, okay, solving these type of problems. Okay, let me show you a couple problems now, okay, and then we can apply how we solve the area between curves problem. This is the area I would like to find out in the first example. So between, right, a polynomial type of, right, this quadratic term, quadratic expression, and then a line, I would like to find out this area. What am I gonna do? First, I'm just gonna be finding out, right, the g of x area, and then the f of x area, right, and I'm gonna subtract them. That's what I will do. But as I said, right, if you think that one, who is the below curve, right, this is the below curve, and then who is the above curve, this is the above curve, right? So is it same always, right, throughout across the whole area? Yes. And that is why I'm just gonna be finding out this area as an integral problem in this way. So I should be, right, subtracting the below curve from the above curve, right? That's what I will do. Let me use my colored pencil. So this is the curve above, right? This is the curve below. That's how I do. So I'm just going to subtract, and I'm going to take care of, right, this integral. But as you see, right, I still don't know, right, what are these bounds. That is another problem I need to find out. To find out, right, the bounds, as you see, my area starts from here, and then it will end here. That is why these are the points, right? These are the intersection point. I need to figure out what are the intersection point. You will remember from the reference section how we could find out, right, the roots, which it gives us the, right, it makes this equality correct. So x squared plus x, and then minus 2 will be 0, and if you solve this quadratic equation, x is going to be either -2 or x is going to be equal 1. You can see the same results, right, from the graph. As you see, this number is -2, which is the intersection point, and then this is the point 1. Okay, that's why, right, I'm just going to write it down, these points here, -2 to the 1, and I will solve, right, this problem easily using the power rule, which is going to be 4x minus x cubed over 3 minus x squared over 2 plus 2x, -2 to the 1. Okay, so this should be negative, right, by the way. So it is going to be negative just 2x minus x squared over 2 minus x cubed over 2, 3, and you should be right using your endpoints. If you use the endpoints after doing all the algebraic calculations, you would get, which is equal 9 over 2. Another example. This time we will solve a little bit different problem. What is the difference? The difference is gonna be, I have two area, right? That is the area 2, this is the area 1, okay, since I started from the left. So I had two different areas. That is why I need to figure out, right, the two different integrals, and then I need to solve them. So for both of them, right, I will go through the same process, the below curve and the above curve. That is why you need to be careful, as I said earlier, right? So for the A1, and the bounds, it will be 0 to the 5, as you see, 0 to the 5. And then who is the above curve? Above curve this time is the line 2x minus, right, x squared minus 3x, right? So when I subtract in this way, of course it's gonna be in this way. So 2x minus x squared minus 3x dx. That's gonna be my integral for the first case. So for the second integral, so 5 to the, okay, I don't know what that number is, right? That's why I need to just find out what that number is going to be. How am I going to do that? X squared minus 3x should be equal to x. So if I solve this equation, x squared minus 5x, which is equal to 0, and then x either 0 or x is 5. So this is just about, right, the first area. What is this line, which it is not given, but let's choose, right, this as 6, correct? You can just take any points there, right, if it wasn't given. This is the area problem. So 5 to the 6, but this time, who is above? The parabole is above curve. That is why x squared minus 3x minus 2x needs to be solved. Okay. If you solve these both problems, right, after taking the integral and then using the endpoints, okay, will give you this, which is 71 over 3. So as you see, right, I need to add these answers after taking the right integral using the power rule. That's how I do it. So this example showed us, okay, how I can use the area between curves problem for the different areas, guys. It is time to apply this idea to the real world problem. We have a nice example here you are going to see. This is a pollution problem, and then we are being asked how the pollution filter is effective, or can we calculate, right, the amount of the pollution at any just right a lake or some other places, right? Look at it. As long as you know what is the rate of, right, the pollution, and then the pollution filter cleaning rate, let's say, okay? So the filter, right, tries to remove the pollution by this rate. Okay, if these are the rates, of course, if you need to figure out what are the antiderivatives or these functions. Why? Since if you can find the antiderivative of these functions, you can just say, right, that the amount of the pollution or the amount of the removed pollution at any time. That is why figuring out the antiderivative is so important for us for the pollution and the cleaning of this lake. That is why, if okay, let's start by this question: how much pollution is in the lake after 12 hours? What would you do? You would just subtract the amount of the pollution and then amount of the removed pollution. That would give you the amount of the pollution in the lake. That's why I can figure out this question in this way. I can find out the antiderivative f, and then I can find out the antiderivative g, and then I can subtract them. As you see, this is just the area between curves problem, even though we don't see the graph here. So what are the bounds? Since I'm just wondering, what is the amount in the first 12 hours? What I'm gonna do, I'm just gonna take the integral, finding the antiderivative, basically. So 10 times 1, which is gonna be 10, and then the derivative integral of the 10 is going to be 10t, and then the integral of this guy will be, right, you just need to put that coefficient to the bottom, and then you need to keep the exponential function same when you integrate, and then this is just a power rule, right? So I just multiply the 10 by this one, and then now it is time to use the bounds right here. If you do the calculation, you are going to see after, right, the 12 hours, we are going to have that much pollution. Okay, so if I'm wondering, okay, when actually the rate of the pollution and then the rate of the removed pollution will be equal each other, what would I do? I would just calculate this using some calculator, right? Finding the time, so making them equal each other. But after that, right, if that's the right number which they are equal each other, what is the real, right, the pollution at that time in the lake? So this is the same question with the first one. I will just follow the same procedure. I'm just going to take the integral between, right, these two functions and then use the bounds to figure out the amount of, right, the pollution in the lake. As you see, it increased, but I know that at least, right, after this hour, it will decrease, since I know the pollution and the removing rate now are equal. Of course, the pollution will decrease if I keep continuing to removing the pollution. So if you see, right, how much important to know such an information, that is why we use the calculus, okay, to figure out these type of problems. So as long as you have this type of model, look at what I can do with this type of model in the real world, guys.